the input is given to the first stage, and the first stage amplifies the signal, and by using the coupling element here you get the some voltage output from the first stage, and this is now connected as a input to the second stage, and by means of coupling element. So the second stage further amplifies the signal, and this is now given to the output. So the output voltage collected by using the these terminals, or else it is connected to the load. Right. Let us see the circuit diagram of the two-stage transformer coupled amplifier. So here you observe the two-stage transformer coupled amplifier. See the difference between RC coupled amplifier and a transformer coupled amplifier. Only the difference is collector resistor RC and coupling capacitor CC both are removed, and these are replaced with the transformer. And see uh, how this two-stage transformer coupled amplifier arrangement is there. See, V in that is input voltage is given to the transistor Q1 first stage transistor through the C in. So input capacitor is necessary here. Uh, Now uh, R1 and R2 are the coupling elements. R1 and R2 are the coupling elements. Sorry, R1 and R2 are for the biasing. R1 and R2 for biasing for both the stages, that is first stage and second stage. The coupling elements are transformers here. So two transformers are going to be used here for the coupling of first stage to the second stage, one transformer, and second stage to the output is another transformer. Okay, here if you observe the first stage and second stage connection, so there is no physical connection between the first stage and second stage. Only secondary of the transformer 1. If you say this is a transformer 1, okay, the secondary of the transformer 1 is connected between uh, a wire which is in between R1 R2 and a transistor Q2. It was there in a RC coupled amplifier, but here this wire is replaced with the secondary of the transformer coil. So here this is this coil is now replaced by the replacing the wire between R1 R2 base of the Q2. So here it is a transformer on secondary coil. So if the input is given at the transistor 1 base, then there is a voltage developed across the collector, and which now develops the due to the mutual inductance, there is a EMF induced in the secondary of the transformer. So this EMF is now the input of the Q2, because it is in between R1 R2 and base of the Q2. So the base of the Q2 gets now the input voltage due to the secondary induced EMF of the transformer 1. So here this input again now amplified by the transistor action, that is by the second stage transistor Q2, and now there is a voltage developed across the collector of the transistor Q2, and now which induces the EMF in the primary of the coil, and due to the secondary due to the mutual inductance, the secondary coil of the transformer 2 will gets EMF here, and this is the output which is connected to the RL. What you understood with this two-stage transformer coupled amplifier? If you give the input voltage at the base of the transistor Q1, which amplifies and which is developing the EMF at the primary of the transformer 1, and the transformer 1 secondary gets induced with the mutual inductance, and this secondary is now driving the base of the transistor Q2. So again it is further amplified by the Q2, and the same voltage developed across the collector of the Q2, and which induces the EMF in the secondary of the transformer 2, which is the output of the second stage. So this is the final output of the two-stage transformer coupled amplifier. Here the two coupling transformers T1 and T2. T1 is for coupling the first stage and T2 is for coupling the second stage to the output. Here let us discuss the circuit details of a transformer coupled amplifier again. The coupling transformer couples the AC output signal from output of the first stage to the input of the next stage, that is a transformer 1, and the output transformer couples the output signal to the load, that is a transformer 2. The resistors R1, R2 and RE are providing the biasing and stabilization for the transistor amplifiers, and the C is a emitter bypass capacitor used in the across the RE to bypass the AC during the stabilization process. Operation of the transformer coupled amplifier. Due to the low voltage and the power gain of RC coupled amplifier, the drawbacks of the RC coupled amplifier, to overcome these drawbacks of the RC coupled amplifier, the transformer coupled amplifier is now preferred. The transformer coupling is generally employed when the load is very small. The transformer coupling is mainly used for power amplification. Why it is used for power amplification? Let us uh, discuss in the next topic. Why it is used for power amplification, and why the RC couple is used for only voltage amplification. Okay. Uh, the transformer is more efficient in providing DC isolation as compared to RC coupling, because in some cases at low frequencies and high frequencies, due to the capacitor placed for coupling, the capacitor is acting like a short circuit high frequencies and acting like a low uh, open circuit for low frequencies. Okay, of course at low frequencies it is no effect of this DC isolation, but at high frequencies it is acting like a short circuit, so there is no DC isolation. But in whereas in a transformer coupled amplifier, uh, it is the first stage, second stage both are physically not connected, so it is isolated completely with the from the DC supply. Let us go to the operation of the transformer coupled amplifier. So as the input signal V is applied by to the transistor T1, and which is amplified by the transistor T1. The amplified output of the transistor T1 appears across the primary winding of the coupling transformer. So we have discussed everything in the early at the time of circuit diagram, but again I am explaining all this operation of this transformer coupled amplifier. So as the transistor T1 amplifies the input signal, and the output appears across the primary winding of the coupling transformer. So and the induced secondary voltage is applied to the base of the second stage of the transistor. Because of the mutual inductance, so there is a EMF induced in the secondary of the transformer 1. So and now which is applied to the base of the second stage transistor, that is T2. Okay, and the second stage further amplifies the signal. So the output is taken across the secondary of the output transformer. Because of transistor action, the second stage further amplifies the signal, and the amplified signal appears across the collector of the second transistor. This voltage now induces the EMF in the secondary of the transformer, because the primary is connected to the collector of the transistor 2. Okay. The overall gain is increased because the input signal is amplified twice by the transistor 1 and transistor 2. So as it is amplified twice, the overall gain of the input signal is increased. So, so before going to the frequency response of the transformer coupled amplifier, let us just rewind the gain and bandwidth of the multi-stage amplifiers. Okay, the gain. What is the gain? Uh, which is already discussed in the last class. The ratio of the output electrical quantity to the input electrical quantity. And what is the bandwidth? The range of frequencies over which the gain is equal to or greater than 70.7% of the maximum gain is known as bandwidth. Uh, Frequency response. The frequency response, which is a curve drawn between voltage gain and frequency of an amplifier. Gain. The definition of the gain, we know the ratio of output electrical quantity to the input of the amplifier. So electrical quantities are voltage, current, and power. Accordingly, the gain can be voltage gain, current gain, and the power gain. So here